Hello, this is Mrs. Taylor, and I'm going to show you how to read a velocity graph. So in this scenario, it says a student walks in front of a motion detector that records her velocity at 1 second intervals for 36 seconds. She stores the data in her graphing calculator and uses it to generate the time velocity graph shown in figure 3.25. It's this figure here. Describe her motion as a function of time by reading the velocity graph. When is her speed a maximum? So in this graph, the thing you have to remember is this is not her path. It is a graph of the velocity. So this is not she moves up, she stands still, she moves down. This is velocity is increasing and is positive. Velocity is not increasing or decreasing, but is still positive, and so on. Your y values are your velocity. So if I were to interpret this, she's moving in front of a motion detector. So she's moving away from and towards the motion detector. So when velocity is positive, that indicates her moving away from her starting point. And when velocity is negative, that indicates she's moving towards her start point, so backwards. So if I wanted to interpret this, it says it's 1 second intervals for 36 seconds. And down here they tell you that the x values are from -4 to 36. So that means that each of these tick marks represents 4 units, or each of these tick marks represent 4 units. So this intersection here where it crosses the x-axis, this isn't 3.5. This is 4, 8, 12. Let's say approximately 13 seconds has passed. So it's really important that you notice what the window is for our graph to start with. Alright, so what we have here is we have positive y values, so that means positive velocity, for the first 13 seconds or so. And so I would say that the student is moving away from the motion detector for the first 13 seconds. This flat line here just means that her velocity wasn't changing. She was moving at the same rate. And then at 13 seconds, she starts moving back towards the motion detector. And then we have this flat line right here along the x-axis. That means velocity is 0. So if velocity is 0, that means she's not moving. So from 13 seconds to, let's see, 4, 8, and then we have a few here, so we'll say 11, maybe 12, 13. So for the next 13 seconds or so, she's traveling back towards the motion detector, and then she stops for several seconds, and then it becomes positive again. So that means she's moving back away from the motion detector. And so the question is, I said, when is her speed a maximum? And remember, speed is the absolute value of velocity. So we're not really looking at positive and negatives here. We're just looking for the greatest absolute value of the y value. So here it dips all the way down to 7.5, and it's negative 7.5. But when we're talking about speed, we only talk about the positive, the absolute value. So it would be 7.5. And here it doesn't quite reach that height. So her maximum speed would be 7.5. And let's say she's moving in inches per second. I don't think it's set up here. It didn't. So in summary, the motion that we've described using this graph is the student moves forward for the first 14 seconds. So from 0 to 14 seconds, because velocity is positive, she's moving forward. And then she moves backward for the next 12. So when velocity is negative, she's moving backwards. She stands still for about 6 seconds here where it's along the x-axis. That's velocity is 0. And then she moves forward again for the last few seconds of the interval. She achieves her maximum speed at t is approximately 20. So right here where it was 7.5. And I misread this. I thought it said what is her maximum speed, but it says when. So that is when you would give the x value as your answer, not the y value. So that's how you would interpret a velocity graph.